Hi everyone, my name is Rupasri and now we are going to discuss about full subtractor. So now we'll see what is a full subtractor and how do we construct that. So now let's see into this. A full subtractor. A full subtractor is a combinational logic circuit. It is used for the purpose of subtracting two single bit numbers. It takes into consideration borrow of the lowest significant stage. Thus, full subtractor has the ability to perform subtraction of 3 bits, and the full subtractor contains 3 inputs and 2 outputs. Let us consider the 3 inputs as A, B and B input, B in, and the 2 outputs as difference and borrow. The notation of difference is D and the borrow notation is B out. So now let's see what are the 4 steps we require to construct a full subtractor. The step number 1 is, in the first step we have to identify the input and output variables. As we have already discussed that input variables are A, B and B in. The input variables either may be 0 or 1 and the output variables are D, B out, where D is the difference and B out is the borrow. And now we'll see the step number 2. The step number 2 is to draw a truth table. Here the inputs are 3, so we take A, B, B in and the outputs are 2, B out and difference. Now we have to draw a truth table. First 0, 0, 0 and the borrow is 0 and the difference is also 0. 0, 0, 1, the borrow is 1 and the difference is also 1. 0, 1, 0, the borrow is 1 and the difference is 1. 0, 1, 1. The borrow is 1 and the difference is 0. 1, 0, 0. The B out borrow is 0 and the difference is 1. 1, 0, 1. Borrow is 0 and the difference is also 0. 1, 1, 0. The borrow is 0 and the difference is also 0. 1, 1, 1. The borrow is 1 and the difference is also 1. Now we draw a truth table. So now let's see what's the third step. So we draw a K-map using the truth table. So let's see how to draw these K-maps. As this is 3 variable K-map, we have to draw a 3 variable. As the inputs are 3, so we have to draw 3 variable K-map. So let's see where do we get ones in the difference table. At 1, 2 and 4 and 7 we got 7 ones position, so we have to point out the second position, first position, fourth and seventh, and we have to loop the ones which are present in the K-map. As there is no looping possible, so we have to draw an individual one. So let's see how we draw this. This is the first one and here we get as A bar, B, B in. And at second position we get as A bar, B, B bar in. And at third one we get as A, B bar, B bar in. And at fourth position we get as A, B, B in. So we have to add all these and we will get as we have to add all these, so we will get as A XOR B XOR B in. Now we have to draw a K-map for B out. So here also it is a 3 variable K-map. So we have to draw and we have to loop. We have to consider where the ones we get. So let's see the truth table ones. Now let's see the K-map ones. Truth table to draw a K-map for B out. So here where did we get ones? At first and second, third and seventh position. So we have to represent ones in first, second, third and seventh position. We have to loop them. So at first position we have to loop with the beside one, that is third position. So 1 1, and we will get as A bar, and which is common B in. So B in at first position, and at second position here the looping one also takes into the looping if one of the non-looping element is present. So at second position we get as A bar, and which is common here B. So A bar B. And at third position we get as B in. We have to add all these. So now we will get the B out. Now we have seen that it is completed K-map, and now we will move into the fourth step, that is how to draw or how to design a full subtractor. So in the difference we get A XOR B in. So we have to draw an XOR gate. We obtain difference D, and here the B out, the borrow is A bar B plus A bar B in plus B in. So we have to draw at the first logic gate we obtain. Here we have to take 3 AND gates and 1 NOT gate to obtain B out. At first AND gate we obtain B A bar B, and the input variables of the first NAND gate are A bar and B, and the output of the first AND gate is A bar B, and the input variables of second AND gate is B in A bar. So the output is A bar B in, and the input variables of third AND gate is B and B in. So the output becomes B and B in. And now we have to connect all these 3 AND gates to an OR gate. We obtain the summation of all these AND gates outputs, and we obtain as the borrow A bar B plus A bar B in plus B in. So the design of a full subtractor is completed. Thank you.